Hi to everyone. My name is T. Rajshekhar, working as a lecturer in civil engineering, SRS Government Polytechnic Sicily, 5th semester, and I am going to teach you the subject reinforced concrete structures. So this subject is for the civil engineering final year students of 5th semester, and the subject code is 501. So let us start our introduction to RCC and principles of working stress design. Objectives: on completion of this class, you would be able to know ingredients of RCC and explain the functions of reinforcing steel, state the codes used for RCC design, and state the loads to be considered. So here actually, so what is RCC? Reinforced concrete structures. The RCC is an important subject for the civil engineering. So the RCC is also called design structures because the RCC subject is totally a designed subject. Here in the RCC reinforced cement concrete, we are going to design the everything of civil engineering structures. For examples, if you see a building, an example. So a building starts with the bottom of the foundation to the top of the plinth and up to parapet wall. So here in the components of a building, you can see a footing. So we will be going to design a footing length and breadth, and what is the capacity of that footing and how much load it will be beared. We will be designing the footing size and depth of the footing. And next, from the footing, the column will be raised to the top of the building. So we will be designing the column section also. How much the column size should be provided, and how many diameter of bars, number of steel bars should be provided in the column. That also we will be going to design. And next we are going to see the main structure, that is coming to the simply supported beams. So we will call generally a beam. So actually what is a beam? A beam is a structural member which is of horizontal, consists of loads and bears the loads. So it is called a beam. So these beams are so many types. For examples, simply supported beam, cantilever beam, overhanging beam, continuous beam. Okay, so these are the some of the types of beams, and upcoming classes we are going to see the diagrams of the beams and how the loads will be shared by the beams. So let us see now, in the first chapter we are going to see the design concepts of the RCC, and you are going to know the some of the materials and steel, what are the we are going to use in the design principles. Let us start here now. What is the reinforced cement concrete? So in the meaning itself we can see here, reinforced means it is called steel. What is steel? A steel is a structural member which consists of aluminium prepared with steel bars. Okay, so it is called the reinforced. And what is cement? A cement is also a material which is prepared by lime and clay. Okay, and what is concrete? A concrete is a member which is mixed of with cement, sand, aggregates and water. So it is called concrete. So whatever these three are mixed here, reinforced cement, concrete, is called a design. So from these three we will be getting the design. So here what are the ingredients of RCC? So what are the ingredients of RCC? Coarse aggregate, that is of plus 4.75 mm. So what is this 4.75 mm? It is called a sieve, okay, which is done from the sieve analysis, which is passed the material from the 4.75 mm sieve is called coarse aggregate, okay. And here fine aggregate, which is there, you can see it is called minus 4.75 mm. So the above, which is 4.75 mm, is called coarse aggregate, and the below, which is 4.75 mm, is called fine aggregate material. And the cement, it is a binding agent material. This cement is called binding agent because it mixed with sand and aggregates and with the water, so then it forms the a binding agent material, okay. So cement has good durability and strength because of the cement only is the main component in the RCC. And next one, water is called potable water. So what is potable water? So which is pH 7, the acidic water or naturally or below or above the which is used. The normal water for drinking purposes is called potable water. So the acidic water we have to not use, which is pH less than or above 7, okay. And reinforcement, it is called steel, the reinforcement which is prepared by the steel. And we are having the two types of steels, that is called mild steel, and we are having the Fe415 grade steel, and another one is called uh, Fe250, so that is called mild steel, okay. And we are having the HYSD deformed bars, okay. HYSD means high yield strength deformed bars. So those are Fe415 and Fe500 grade steel, okay. So let us see what is the coarse aggregate here. So the coarse aggregate, which is quality of coarse aggregate should be there. So it is from the gradation, okay, that is well or poorly graded. So this will be done from the quarries and it will be washed away the dust which are there, and next we will be testing in the laboratories. So that is nothing but well or poorly graded, and the shape should be triangular or rounded, okay. The shape of the aggregate should be triangular or angular also, we will say angular shape also, but not we will use moreover rounded shape, but it should be angular and flaky shaped, so that bonding will be very good in the concrete. And durable, the aggregate strength of the should be very durable. So the durable means the toughness and strongness of the aggregate, okay. And it should be chemically inert. The aggregate should be chemically inert, it should not be spoiled by the chemical. So it should be able to bear the chemicals also. And what is called fine aggregate, let us see now. So these fine aggregates are, the quality also should be very good, and the grade, there are three types of fine aggregates are there. Those are, first one is coarse, and the second one is medium, and the third one is fine. So we are having three types: coarse aggregate, fine aggregate, and medium aggregate. So these are defined by the sieve analysis test. And bulkage should be very less, whereas comparing with the coarse aggregate, so it should not be breakable or anything cracks, and it should be free from deleterious materials. So whatever the aggregates we are using in the concrete mixing, they should be free from everything. So they should be the no dust and no papers or anything. So that is called deleterious materials. And the next one is cement. So cement is the heart of the RCC. And cement, it is function in concrete, acts as binding material. So for every structure, the cement is the main component material. So without a cement, we cannot construct any structure. Okay, so these cement are also, so many types of cements are there. So generally in every construction we are using the ordinary Portland cement, OPC. So we are having the cement grades also. So here you can see there are types of cement: OPC, ordinary Portland cement, rapid hardening, sulfate resisting, PPC, Portland pozzolana cement, hydrophobic, expanding cement, high alumina, quick setting, high strength cement. So these are the types of cements which are used in the binding material. So generally we prefer the grades of cement. So we are having some of the grades, that is 33 grade, 43 grade and 53 grade. So here the 33 grade cements are used for the small petty works, just like for the plastering or in the footing cases. Whereas coming to the 43 and 53 grade cements, these are used for the high strength concrete works. Whereas starting from the foundation to the top of the building in slabs, columns and beams, or in the staircases and in the lifts. So this 43 and 53 grade cement is preferable. So we are having so many types of cement companies also. In that we have to see a good type of cement should be used. So generally in the constructions we prefer the OPC cement and rapid hardening cement. Because comparing with the OPC and rapid hardening, OPC has minimum durable strength, whereas comparing to the rapid hardening, it has very high strength durability. So here we are having some test also. First one is called fineness test of a cement, and the second one is consistency test of cement, and the third one is setting time of cement, and the fourth one is compressive strength of cement, and the fifth one is soundness test of cement. So these tests are done before used in the construction activities. So this test has to be do very important compulsory. So based on these results, the cement should be used in the construction works. So fineness means the fineness of the material of the cement will be known. How much the thickness and fineness of the cement is there. So it will be done by the test. And consistency and setting time test are known as the cement setting time. So whether as the cement is mixed with water, it will be durability and having this strength and consistency up to the certain time. That is, our initial setting time is determined as 30 minutes and final setting time is determined as 600 minutes. So it is called 10 hours. Okay. So in the testing laboratories we will know the initial setting and final setting time cement. And compressive strength of cement. These compressive strength of cement will be known when the concrete is done in the made up of cubes. Those are we will call as cement cubes. So the cube size will be the 15 by 15 by 15 centimeters. So this is the standard size of the concrete cubes. So these cubes are mixed when the concrete, and they will be kept by layer in that cube molds, and after 7 days, up to 7 days we will keep in the water, and after 7 days we take their samples and will be tested in the laboratory, and next after 28 days we will take from the water and we will be tested from the laboratory. So for 7 days you will get the 35% of results, and after the 28 days you will get the 80 to 90% results. So that is depending upon the mixing of concrete. Okay, so then we will determine the characteristic compressive strength of concrete. Okay, so that is determined as in the ratios M15, M20, M25, M30, M35 grades. And next one is soundness of cement. The soundness is nothing but the quality will be determined. What is the cement and how much the soundness the cement should have. So it is determined by the an apparatus. Okay, the soundness test apparatus also will be there. So these are the main uses of the cement, and here you can see the grade is also mentioned. So grade is the strength of cement mortar 1:3 and cubes at the end of 28 days curing in MPa. So we will get the by the compressive strength testing machine in by load, that will be Newton per mm square or MPa megapascals. So 1:3, that is called, 1 is cement bag and 3 is sand. So here we will have the ratios also, 1:2:4, 1:3:4. So we are having so many ratios also. And the next is available grades are 33, 43, 53. So just what I have said now, the grades are 33, 43, 53. And next is the very important component, water. So how the cement is used in the construction? So water is also periodically daily used in the construction. So the water should be the potable condition. So no any other dirty water or rainwater or any river water is used, or any boring water is also not used. The potable water which is used for the normal drinking purposes, that water only should be preferred for the concrete works, because if any other water we have used in the construction, so the water will spoils the structure and it will be getting the cracks after the some of the days, and the structure will be failure slowly and the cracks will be evaporated, the material will be not mixed properly, so the damages will be occurred. So that is due to the water reaction. So if the water is good, the cement concrete also will be the mixing will also be good. So that is regarding the water. And now next we are going to see reinforcement types. So this is very important. So the reinforcement is the another important topic in the RCC. So how the cement is performing its duties in the RCC, whether as reinforcement is also performing the duties. So here you can see MS and medium steel tensile conforming to IS 432 part 1. So what is MS here? Mild steel, and medium tensile steel conforming to IS means Indian standard. So that is the code, Indian standard code 432. So the steel code book we are having, that is we will call part 1. So from that we are going to determine the steel grades, and HYSD bars conforming to IS 1786. So high yield strength deformed bars. Okay. MS means mild steel. HYSD means high yield strength deformed bars. So comparing with the mild steel and high yield strength deformed bars, whereas mild steel bars are will be in the plain color. Okay. The next is here comparing with the mild steel bars, are they will be of just plain type, okay, plain smooth type. But comparing with the HYSD bars, these bars are with rough coated with angular shape. Okay, we can see the written Tata Steel or Jindal Steel. So the names will be there, which are IS 456. Okay, and you can see hard drawn steel wire fabric conforming to IS 1566. So this third one, hard drawn steel, we are used in the generally large constructions, just like power plants, okay, and there are you can see very large industries we will be using. So it is confirmed as IS 1566 code, and here the reinforcement steel should be free from loose mill scales, rust coats of paints, oil, mud, etc. So whatever the steel we are using in the construction, they should be free from loose mill scale. Loose mill scales means the steel bar should be very strong and durable. It should not have any cuttings on that, and rust coats, corrosion or any painting marks, and any oil or any liquid type should not be there, and any mud also should not be attached to the reinforcement bar. It should be very clean and very tidy used in the construction. So then only the building will be the strong up to the lifespan. And here the steel, reinforcement steel, the it is determined as ES is equal to 200 kilonewton per mm square. So this is determined as ES. So characteristic yield strength is equal to minimum yield stress by 0.2% proof stress. So it is called the characteristic yield strength. The characteristic yield strength is determined by minimum yield stress by 0.2% of proof stress. So next we are going to see the reinforcement functions, how the reinforcement will be used in the RCC. So the reinforcement is used for to resist the tensile stresses. So what is the duty of the reinforcement here? It will be resisting the tensile stresses. So we are getting the so many loads in the structure, just like compressive stresses and tensile stresses. So whatever the loads are acting in a structure, so it should be bear the loads. So here the concrete will be in the compression, whereas steel will be in the tension. So that is called compression, and tension is nothing but sagging and hogging. Okay, so I will explain you what is coming sagging and hogging in the upcoming classes. So to reduce the size of the section, so this reinforcement function, it will be used in the designing structures. It will be reducing the size of the section also. So depending upon the diameter of bars, the size of the section will be changing. And it is to take care of temperature, shrinkage and shear stretches. So this reinforcement bar will take the temperature and shrinkage. So what is the temperature? Temperature will be of climatic seasons, and the shrinkage any other water leakages or any cracks, so which appears in the structure, and shear stretches which are there, which will be appearing from the loads. Okay, so the loads which are distributing in the structure, those will be of shear stresses. So it will be taking the care from these types. And next is codes used in RCC design. So we are having some of the codes. So for RCC we have to take the IS 456, Indian Standard 456 2000 code book. So in that you will have all the design processes. So that is called IS 456 2000. And we are having the IS 875 1987 slash 2006 code book also. So we can use the second one also. And in second one you can see part 1 is called dead loads. In IS 456 2000 you can see part 1 we are having dead loads, and part 2 live loads, part 3 wind loads, part 4 snow loads, part 5 miscellaneous loads and load combinations. So we are having the dead loads. What are the dead loads? The structure load which is acting on the which are beams, columns which are acting on the structure is called the dead loads. And the live loads, which are the structured loads, which are known as live loads. And the wind loads, you can see from the temperature and atmosphere what we are having, the loads are called wind loads. And snow loads, it is also just like from snow which is appearing on the structure, it is called snow loads. So miscellaneous loads and load combinations which are appeared to, because a structure is open to the atmosphere. So we are having so many loads. Just miscellaneous loads, you can see earthquake loads will be coming on, or any temperature loads will be coming on. Okay, so different types of loads will be acting on a structure. So these are all called loads. And in coming to the IS 1893 earthquake resistant design. So this code is derived for the earthquake structures resistant design. And SP, this SP is called standard publications, remember. Okay, standard publications 1980 design aids for reinforced concrete. So standard publications SP16 1980 is used for the design aids for reinforced concrete. And SP Standard Publications 24 1983 is used for explanatory handbook on IS 456 to 1978. So this is a code book which is derived for the from the Standard Publications 24 to 1983. So we will have the RCC code book handbook, that is regarding the explanatories will be there. And the sixth one is Standard Publications 34 1987 Handbook on Detailing of Reinforcement. So in this handbook we will have the all the details of reinforcements, whether as coming to the how the bar will be bending and what are the cutting sections and what are the types of steel bars are used, what are the materials are used in the steel. So that will be the detailing of reinforcement. And SP 23 1982 Handbook on Concrete Mix Design. So it is used for the concrete mix design. So this concrete mix design is also another one part of the concrete works. Next is loads to be considered in design. So the dead loads, so live loads or imposed loads, wind loads, earthquake loads and snow loads. So these are the 5 types of loads we are acting on the structure. So coming to here dead loads. What are dead loads? Let us see clearly. These are mainly due to self weight of the structure. So just now what I have said, this is the self weight of the structure. So normally a self weight will be there for a, because how this self weight will come of the structure? By structure when it is built its own, okay, when the structure is built from the bottom of the top of the slab, it has some weight. So the total which is called, it is called self weight, okay. And permanent or stationary loads, so these dead loads will be permanent or stationary loads, because actually we will say permanent loads because if the structure is started then the weight will be started. So when the self weight is started, that is called permanent load, okay, we cannot change it, and it occurs throughout the lifespan. So just now what I have said, that is only the you can see. So the load which is started when the structure which has started from the bottom of the footing to the top of the slab. So if it is constructed, the load which is there in the dead load, the self weight of the structure, it will be up to the life of the span of the structure. And how to calculate, you can see, can be calculated by knowing unit weights of materials. So if you know the unit weight of material, you can be calculate the self weight of the structure. So that is IS Indian Standard 875 Part 1. You can see in the Indian Standard 875 Part 1 this regarding the dead loads, because this dead load is very important in the structure. So these dead loads are used in the not only in the buildings, in the columns or in the bridges. So in every civil engineering structures, these dead loads will be commonly there. So that's why to calculating the total load of a structure, we will be taking the dead load, live load, wind load and snow loads. With that we will calculate the factor of safety of the load of the structure. And the next one is live loads. So what is live loads? It is change with respect to time. So one example I will say, if a person, if an empty building slab is there, so if empty slab is there, in that there will be no live load because there is only the self weight of the load. If the persons or any structure, okay, any other items which are kept on the slab, so that means what is happening here, when the structure is on the structure, any loads are moving on the stretcher, so that is called live loads. So coming to the persons or any other items which are kept, so those are called live loads. So that's why here it is saying that it will be changing when the respect to time, and it can be calculated using IS 875 part 2. So we can check these live loads in the stretcher, that is in the IIS 875 part 2 codebook. So by using these, the live loads can be calculated. And the next one is wind loads. So they are horizontal loads caused by winds. So we everyone know the wind will be in generally conditions normal, but sometimes the wind will be changed in the rainy seasons or in any other type climates. It will be very strong and durable. So in order to resist these wind loads, we will be taking the a constant values. So that is depending upon velocity of wind and shape and size of building. So the wind load will be changed. So it can be calculated using IS 875 part 3. So remember, these are very important for the competitive examinations also. Okay. So here it is calculated by using IS Indian Standard 875 part 3. And next is earthquake loads. So these earthquake loads are when the earthquake will be coming, they can be resist the loads. So in future, in any time the earthquake will be coming or not, we don't know, but we have to take the earthquake loads also. So it is caused by earthquakes, and these are called horizontal forces because when the ground moves either left or right, okay, or shakes the ground, or vibrations will occur in the ground level, so that's forces we will call it as horizontal forces. And these earthquake loads also can be calculated using IS 1893 to 1984. IS 1893 to 1984. This is the Indian Standard Code. And the next one is snow loads. So these snow loads are applicable for building located in areas of heavy snowfall. So normally in all buildings we will not take the snow loads, but in the snowy areas which are there, just like hilly areas or very cooled regions, there the snow loads will be taken compulsory. And it can be calculated using IS 875 part 4. So you can observe one thing here, the for each load the each code is changing, that is nothing but part 1, part 2, part 3, part 4. So from this only we can calculate the, or we can take the constant value. So once again let us see here back the live loads and dead loads also. So this is the part 1, and live loads are, you can see part 2, and we can see these are the wind loads part 3, and earthquake loads are also part 3, snow loads are part 4. Okay, so these are the loads which we are using in the RCC construction, and you can see moreover these codes are very important. The standard publications and explanatory on handbook, but here we are using for our design purposes IS 456 2000 code book. So this is applied, this is available in the market and in the online also. So this IS 456 2000 standard code book is used for the RCC stretchers nowadays, and this is very simple, and we are having the working stress method and limit state method. So in the previous, the working stress method has used for the designing of stretchers, but whereas in the working stress method, some of the difficulties were faced, but comparing to the now limit state method, it is very easy and understanding to the everyone, and we can use the limit state, and the limit state stretchers are also now in a safe condition. So by using that method is very safe nowadays. So here we are having the so many functions what we have seen, what the reinforcement does and what the cement does. Okay, what are the functions of cement and reinforcement. So these are the some of the cement names we have seen. So these grades are also occurred by testing in the laboratories. So how these 33, 43 and 53 grades came. So these are tested in the laboratories, that is nothing but 28 days of compression strength of concrete. So then they will be determining the depending upon the megapascal load and Newton per mm square load. So they will be naming it as the type of grade. Okay, so depending upon the grade, the cement also will be there. And these fine aggregates are also, whereas coarse, medium, fine, uh, these are available in the market also generally, but generally we prefer the very fresh aggregates which are available from the quarries. Okay, so that is used in the fine aggregates, and we can see the sand also we will call the fine aggregate, so which is of river sand will be good for the construction, and there should not be any bulking in the sand. This will be known by the testing of bulking of sand. In that we can see how much dust is present after a few hours in the a glass jar or any bar, and issue deleterious materials which are there just like paper or iron, any other cloth type items, they should not be mixed with the fine aggregates. And coarse aggregates are also preferred very good materials which are in a triangular or angular shape. So they should have very good strength and durability, because in the concrete which are mixed the material, they should bear the very heavy loads. So if the material is having good strength and durability, the structure will have long lifespan. So if the material has very less strength, then we cannot give the long strength. So here this is chemically inert. The materials which are used, they should be inert from the chemicals also, just like acids. Okay, any other items which are mixed with the aggregates, so they should be cleaned in the using of RCC. So you can see this is a 4.75 mm sieve size, so it will be of round. Okay, so this sieve which is there used in the laboratories. Okay, from this the material which will be passing. Okay, so the aggregates, okay, which are passing. So but the material some will be resisting on the sieve. Okay, but this sieve will be 4.75 mm size. So whatever the materials which are resisting on the top of the sieve, those are called coarse aggregates. But which the material is passed from the 4.75 mm sieve to the another bottom of the sieve. Okay, so this is the last sieve. So which is resisting here the material or which is passing, it is called fine aggregate. So remember, this is very important. So these tests should be done in the laboratories compulsory before using the in the mixing of concrete. So whereas the water is also main thing which should be tested in the laboratories, whether it is a acidic water or normal water or any other potable drinking water. Okay, so maximum we have to use the good potable water in the concrete structures. So these are the things we have discussed today. So now next upcoming class we are going to see the in the code book some functions also. So remember, dead loads, live loads, wind loads, earthquake loads, snow loads are very important. So finally summary. In this class we have discussed about today ingredients of concrete, types of reinforcement, functions of reinforcing steel, codes used in RCC design and loads to be considered. Okay. So I hope everyone have understood. Thank you. Have a nice day.